Hi everyone, in this video I'm going to introduce a concept called a system of linear equations. In the process of introducing this concept, we will define a new mathematical object called a matrix, which is kind of like the extension of a vector. We went from scalars or numbers to vectors. Now we'll be going from vectors to this matrix object. Before doing that, I'm going to give you a concrete example that gets a little bit into what we're talking about with these problems. This is a puzzle. We have three different characters buying different grocery lists. We know what they bought, we know what the total bill is, but we don't know how much each thing costs. So Felix, with 3 bags of apples, 1 bunch of bananas, and 1 coconut, has a total bill of $16. Sam, different list, 2 bags of apples, 1 bunch of bananas, 2 coconuts, 13. Tanya, 1 bag of apples, 3 bunches of bananas, and 2 coconuts, total 15. With that information, can we find out how much it would cost us if we went in with a 4th grocery list? 4 bags of apples, 2 bunches of bananas, and 3 coconuts. Can we determine that information even though we don't know how much each of those 3 objects costs on their own? If we did, it'd be really simple, but we don't. To proceed, what I'm going to do is I'm going to take those 3 sentences at the top and I'm going to convert them into mathematical language. I'm going to let apples equal A, bananas equals B. Actually, I don't want to draw those lines underneath because it looks like division. So apples I'll call A, bananas I'll call B, and coconuts I'll call C. And I'll do that for all 3 of the lines. And then rewrite those lines as follows. 3A plus B plus C is equal to 16. So 1 times B plus 1 times C. We don't need to write the 1 there. And then the next 2 are indicated below that. What we're going to do next is something you probably did in grade 9 or grade 10 for solving systems of equations. You may have learned the method of elimination or the method of substitution. I'm going to use elimination and I'm going to use substitution. I'll use both. So what I'm going to do first is I'm going to subtract one equation from another equation. I'm going to take equation 1 and I'm going to subtract from it equation 2. So I'll call this first one equation 1, the second one equation 2, and the third one, not being very creative, I'll call it equation 3. So if we subtract equation 1 minus equation 2, we have 3A minus 2A, which is A, B minus B, which is 0, and C minus 2C, which is negative C. Then on the right-hand side, gotta be careful, I don't need a double equal sign. On the right-hand side, I have 16 minus 13, which is 3. So this is telling me that A minus C is equal to 3. I can isolate, I can get A in terms of C. A is equal to 3 plus C. I get that by adding C to both sides. Okay, for the next, let's see what we can do. Okay, for the next one, what I'll do is I'll subtract equation 2 minus equation 3. I'll do that subtraction. So I have 2A minus A, which is A, B minus 3B, which is minus 2B, 2C minus 2C, which is 0, and 13 minus 15, which is negative 2. So this tells me that A minus 2B is equal to negative 2. And then I can isolate for A. A is equal to negative 2 plus 2B. Okay, what we can do next is we can identify the fact that those 2 equations for A are talking about the same A. They're both saying what A is equal to in terms of a different letter. So I'm going to set those equal to each other. I'm going to say, well, A is equal to A. So 3 plus C is equal to negative 2 plus 2B. And then I'm going to get C in terms of B. So C is equal to minus 5, subtracting 3 from both sides, plus 2 times b. And then I can get a in terms of b. So I'm going to go back up here. A is equal to 3 plus c, which is equal to minus 5, or sorry, 3, am I doing 3 plus negative 5 plus 2b, which is equal to negative 2 plus 2b. That's pretty messy, and it looks like we're not getting very far, but we actually are almost at the end. I have a in terms of b, and I have c in terms of b. What we can do next is we can go to any of equations 1, 2, or 3 and substitute a with what it is in terms of b and c with what it is in terms of b and get an equation of only one variable. And by the way, you will not be solving problems this way. We're going to replace this approach with a far better, more systematic approach. I'm just showing you what we're not going to do so that when you see what we are going to do, hopefully you're less horrified because it's replacing this. Okay, so I'm going to sub a equals negative 2 plus 2b and c is equal to negative 5 plus 2b into any of those three equations. So I'm going to be picky. I'm going to use equation 3. And in fact, it doesn't really matter which one you use. They'll all lead to the same result. You can check that if you want. So here we have negative 2 plus 2b plus 3b plus 2 times c, so plus 2 times negative 5 plus 2b is equal to 15. I'm going to collect like terms. We'll actually simplify the brackets first and collect like terms. So 5b minus 10 plus 4b is equal to 15. Keep collecting like terms. So we have negative 2, negative 10, so negative 12. Add that to both sides, so 27. 9b equals 27. And then that means that b is equal to 27 divided by 9, which is 3. Okay, and now we can go back and find what a is, because we know that a is equal to negative 2 plus 2b, and we can find out what c is, and c is negative 5 plus 2b. So c is equal to negative 5 plus 2 times 3. So c is going to be negative 5 plus 6, which is 1. So the price of a coconut is 1. The price of a bunch of bananas is 3. And then a, the bag of apples, a is equal to, I'll use green just to be consistent. So a is equal to negative 2 plus 2 times 3. So negative 2 plus 6, which is 4. So our grand solution. We know that a equals 4, b equals 3, c equals 1. So 4a plus 2b plus 3c is going to be 4 times 4 plus 2 times 3 plus 3 times 1. So 16 plus 6 plus 3, which is 25. That's how much our shopping list is going to be based on this information. That wasn't very nice. That wasn't very friendly. You're probably looking at those steps, asking yourself, How did you know to subtract equation 1 minus equation 2, and to then subtract equation 2 minus equation 3, and then to set a equal to a and rearrange, and then to rearrange again, and then to sub everything into equation 3? Like, what leads you to follow this type of a process? If I go down a different process, am I going to get the same answer? The answer to that question is yes, as long as you're only subtracting one equation from another, or you're using substitution. So in equation 1, isolating for C right away, in equation 2, isolating for B right away, and then, I mean, no matter how you slice it, if you're using substitution and elimination, you will come to the same final conclusion as this, no matter which sequence of operations you use, which is frustrating because it means different people can follow different methods and get the same answer, which means there's no single method to use. That part's not going away, but what we will do is more systematic than this. Now, the example we just saw was kind of silly. It was kind of, I don't want to say artificial, but we got an answer. The answer was very clean. It was in terms of integers. The answer made sense. Extensions of this process and extensions of these types of systems become non-trivial and become fairly interesting. For example, we could have had a fourth buyer whose bill was inconsistent with this information. We could have had someone buy, let's say, 4 bags of apples, 2 bunches of bananas, and 4 coconuts, which should total to $26, but maybe they said it was $27. So we'd go through the same process and find an inconsistency. If this was an accounting process, that might indicate fraud, that someone in that group of 4 is involved in some type of fraud. They're over-reporting their costs and they're pocketing the difference. There's similar extensions of this to problems in analytics and optimization, supply chain management. This idea of a system of equations comes up in a lot of different areas. That's something you're going to see over and over again. You'll see it in Excel, you'll see it in different programming languages, you'll see it in different courses in different contexts. What we learn in this course is how to solve these systems using like a pencil and paper method, very simple toy models, toy systems, but the methodologies and the foundation is applicable in all these different areas as well. We'll pick up in the next video.